Everyone. It is 10 till 8, so I'm going to turn on my stream and just kind of hang out. You get to see the funny faces that I make as I'm flipping through different screens and getting things set up. You might even hear the family in the background make a noise. That's okay because this is real life. So bear with me. I'll get started in about 10 minutes. Oh my goodness. I forgot to turn off the sounds on the live stream, so you got to hear what I sound like to myself. Confusion. Anyway, if you are joining us and tuning in, there is the URL for the chat. You do not need a Twitter account to use that chat. Just put in the nickname you want to be known as. If you're one of my students, I would appreciate if you would use the calculator code that you use to log into your TI Inspire in class. I'm going to use that just to do a little bookkeeping to keep track of which one of you guys are joining me on the evening. Also, please make sure that after watching, you go to the Google link that is being displayed and take the survey. You can do that before or after. I would greatly appreciate it. Remember, capitalization counts. I am going to try to put a link up in the various chat areas. I wish I could play music, but if I played music that doesn't belong to me, they shut down the sound on my stream, and that would not be helpful. So, yay, Twitch for that limitation of the technology. Sorry. What was I going to do? I'll remember. Hang on. I was going to. I don't remember what I was going to do. I was going to find something for you guys. I was going to find a URL for you guys. I don't remember what it. Oh, the. I remember I was going to get the URL for my survey. I remember now. I remember. It is. Oh, I remember how to do this. There it is. I have it already all typed up, ready to go. There we go. Now we're rocking and rolling. Don't need that tab. So if you're just joining us and I see some people already online, hello and welcome. Thank you so much for tuning in. There's the URL for the chat that you do not need a Twitch account to use in case you are one of the viewers that does not have Twitch and has no intention of signing up for Twitch. And there is the link to the survey that I would like you please to take so that way I can just kind of do some internal tracking kind of things. Remember, if you're one of my students, I ask you to please end the chat. If you're not going to use your whole name, and that's okay, you don't have to, please use your TI Inspire login codes. And I have my handy dandy notebook, and I'll jot down that you joined me. We will be getting started in about 10 minutes. That gives everyone plenty of time to get in to our online class. Itchy nose. Okay, it's 2 till 8. We'll get started officially in about 7 more minutes. So if you're just tuning in, you've got enough time to, if you're going to take notes and follow along with us, you're one of the students, please get some notebook paper, get some things to write with. You know me and my color fixation with the color pen, so you might want some different colored pens as well. We are almost ready to go. I'm just going to give everyone a few more minutes to log in and to join us. If you're watching that Twitch stream, you're watching the chat, there is the um, information for both the chat that we're going to be using, so that way you do not need a Twitch account. And the second link is a link to the survey that I would love for everyone who is watching tonight to please click and please take, even if you're not a student, just so that way I know kind of who's watching me and how many people I've got on the stream willing to take that little survey. So if you'll do that for me in the next few minutes while we're getting started, I would greatly appreciate it. Thank you, and we'll get started in about 6. We'll get started in about 6 minutes. I can count in due time, I swear. I'll be back with you in 6 minutes. All right, it's 8 o'clock, so I'm going to go ahead and start all of the welcome stuff and get this officially underway. Welcome to Webcast episode number 2. This is the second time that I've done this. Thank you so much for joining us. My name is Miss Carranza, and I'm a geometry teacher at La Feria High School in La Feria, Texas, in the Rio Grande Valley. So if you're watching from outside that area, welcome to wonderful South Texas. If you're one of my students, thank you so much for joining in. Today we're going to be talking about how we name the different geometric forms that we've been studying so far, from points, lines, and planes as a quick review from what we've done over the past few weeks, starting here at the school year, moving into how you name line segments, rays, and finally angles, which is the new thing that we started studying just this week. So we've got a lot to cover today. As soon as we get done with naming things, I'm going to do an algebra extension, so we'll be able to go backwards a little bit, and we'll do some algebra using the geometry postulates of segment addition and angle addition in order to solve for values of x and to figure out the length of segments and the degree measures of angles. So we've got a lot planned for this hour. Thank you so much for joining in. And Troy V, thank you so much for putting your calculator code in the chat. Welcome. Thank you so much for joining me. In case you missed it, there are the URLs for you to use our chat that doesn't require login on Twitch. That's the main one that I'm going to be monitoring this evening, and also has the Google link code to the survey that I'd like you to complete, just so that way I have full documentation that you were here and you were watching and you were studying with me. Thank you again so much, Enchoy V, for joining me this evening. I greatly appreciate it. Without further ado, let's get, let's, what am I trying to say? Sounds like class. Without further ado, let's get this ball rolling. All right. Woo! My webcam's starting to fall over. So you see my paper here. It says, "Welcome, yay for awesome perspective." If you were joined me last week, my perspective was crazy, and now I've got that fixed. And I also found the focus on my camera, so you no longer have to worry about being super blurry. Today, as you can see in my picture, we're going to be using some pencils. I should probably choose the one that's been sharpened. So there we go. There's my sharpened pencil. We're going to be using some pens. You can hear me clattering around in my toolbox. I actually brought one of the toolboxes home with me from the classroom. So we're going to be using some pens, and because I'm going to be drawing some different line segments and things, I have a straight edge. So if you have a straight edge that you would like to use, please feel free to pull that out. If you don't have a little ruler, don't panic. If you've got a cell phone, the edge of your cell phone is usually straight. Unless you've got some weird funky case that has like bumps and things, that's not straight. But otherwise, the edge of a calculator or cell phone or remote control or um, I guess this box of snacks, as my daughter yells out, PB&J snacks. Um, Anything that's kind of got a straight, hard edge, you can definitely use as a well as a straight edge. Right, so here we go. Let's review how we name points, lines, planes, line segments, rays, and angles. So we're going to start with points. Those are the easiest things to name. Remember that a point is just represented by a dot, and we use a capital letter. So I'm going to ask my 6-year-old for some help on this. Honey, please make sure you speak up nice and clearly so they can hear you through my microphone. Thank you very much. Can you give me a letter? A. There it is. A big capital A names that point. That's all there is to name points, just a single capital letter. Now, 2 points allows us to name any line that we want. So I'm going to start with 2 points, and I'm going to set a different colored pen just so it looks a little different. Sorry for my hand creating a shadow. I'll have to fix the lighting soon. There we go. There's a line. In order to say that it's a line, I need to put some arrows. And of course, since it's a line, there's an infinite number of points, so I can put tons of points in there. My darling girl, I have 5 points on this line, so I need 5 letters. Ready, set, go. A, B, C, D, E. Okay, we've hit all 5 points. There they are. In order to name this line, you need any 2 of those points. Order does not matter. So I can say that this line is a E, but in order to make sure that it's a line, I have to put the little drawing a line above it. Otherwise, I'm not talking about a line, I'm talking about something else. I said order didn't matter, so I could have named this line EA, Electronic Arts, EA. I don't have to use the ones at the very end. I can use any combination of any 2 points on this line. So I could have done something really fun like BA, line BA. Don't forget the symbol there on top. Ba is the name of this line. So choices are almost limitless. You can use any any 2 points on the line. Make sure you use that little line symbol on the very top to say that it's a line. You're just gonna have to remember 2 points make a line. So any 2 points on that line will name the line. Thank you for asking, my darling. If you don't have any points on the line, You can name it with a small, kind of cursive letter. So a lowercase letter will also name the line. So this one is line T, but when you do that, you have to write out the word line. Line T is another way to name this line. Now, if we're naming planes, and I know that drawing the planes was kind of odd for you guys, for some, we typically draw planes as kind of this squished rectangles, triangles, rectangle, square kind of thing. Typically seen this way. It doesn't have to be. I also, on some of them, accepted, um, I think, some triangles. Some people were drawing triangles. Just remember that when you're naming planes, you've got two options, just like you have two options to name a line.
Mom?
Any 3 points in the plane that do not lie on the same line will name this plane. So, darling, can you please give me 3 names of points? Any 3 letters will name a
Z,
point. Z,
C,
C,
A.
and A.
I like A.
She likes A.
Oh, and I put C for you.
And C is for me. Thank you so much, sweetheart. So Z, Z, C, A. So this name, this plane can be named plane Z, A, C, plain Zach. So shout out to any of my Zachs watching. Order doesn't matter, just like with the line. So I could have easily called this plain C-A-Z, plain Kaz.
Has.
Now,
Anyway,
if your plane has a capital letter on it, usually kind of cursive looking, it's called script. And it does not have a point next to it. So something like this cursively looking K, you can use that letter to name the plane instead of the 3 points. So it would be plane K. But just remember that when you're looking for this kind of scripty letter, sometimes the typesetting on the computer doesn't make it look like a cursive letter. You have to make sure it doesn't have a point next to it.
Mommy?
So the thing to remember when you're looking for points on a plane is that points on a plane will have a point next to it, whereas the name of the plane by itself will not.
Um, can can I say hi?
You are saying hi, they can hear every word you say. All right, so wait, I will ask you for answers that you know the answers to in just a few
Okay.
moments, okay?
Hi. That's what I mean.
Now we're going to move on to the ray. Now, ray is a part of a line, but it's just kind of like half the line. So it's got one endpoint sitting there because it ended someplace, and then it goes off into one direction, any direction you want, to infinity. So it's got the arrow like a line, but it's got this kind of point here where the ray stops. So this is a ray. This is what they look like. And you name them with the endpoint and any point along the ray. So I'm going to put a point right here. My darling girl, can you please give me 2 letters to name 2 points?
PB.
P and B. So this ray only has one possible name that it could be.
And
And that name starts with the endpoint.
and
This
I say
this ray can only be named PB, and the symbol is a small little ray, so a line with just one arrow on the end going from left to right. It's never okay in this case. Wow, I'm realizing that's kind of tiny. I'm very sorry. Let me write it bigger. It's never okay to write the symbol for ray with the arrow on the left. The arrow on the symbol for ray must be on the right-hand side. And since we read left to right, the endpoint must be on the left. Now, I've covered quite a bit so far, so I want to check in. I see some viewers with me. Thank you so much, viewers. If you'll go to the chat that is not the Twitch chat, it's going to be the first link there in the links I have sent on the Twitch chat. Head to that URL, just click on it. It should take you right there. You don't need a URL, you don't need an email to log into that. You can just type your name or your calculator code and give me a smiley face if so far you understood everything. If you have a question, please take a moment to ask that question now. I'll wait just a few moments. Waiting for those of you that are on the TLK chat window. If you understood everything so far, give me a smiley face if you would, please. If you've got a question, now is the time. I'll give you a couple more seconds just to make sure that everything is okay. Okay, I don't see any questions and I don't see any smiley faces, so either you're too shy to chat or the two people that I've got there, I know one is myself, um, not yet ready to use the chat. That's okay. Thank you so much for tuning in. We have covered names for points, names for lines, names for planes, and names for rays. There are two things left that I want to go over, and that's line segment. A line segment is a piece of a line, and since it's just a part, it has definite starts and stops. It has endpoints, one endpoint here, one endpoint here, and we name them by their endpoints. So let me have two letters, please. B and J. And so this line segment's name can be BJ with the little line segment symbol on top. Note it's just a little piece of a line. It has no symbols on any end. This line segment can also be called JB. So like the line, order doesn't matter. Hello, Troy. Thank you for joining me on the TLK chat stream. If you've got any questions, please feel free to post them there. I will see them and respond as quickly as I am able. Do you remember there is a few second delay from when you type something to when you will hear my voice respond to it. So far, so good. Give me a smiley face if you're doing okay. If you have a question or confused on something, please ask that question now. Waiting a few moments for y'all to respond. If you're just tuning in, thank you so much for tuning in. There are the links to the TLK chat, which you do not need to have a Twitch account to use and is the main chat that I am monitoring, along with the Google survey that I would like you please to take. Okay, doesn't look like we've got any questions, so we've only got one last thing to name, and that's the angle. So I'm going to take this ray and I'm going to turn it into an angle by adding another ray that's coming off that same endpoint as my first ray was. So it shares this endpoint. There it is. Since it's a new ray, I need to put another letter on it. Thank you. I got your It's Okay, Troy. Thank you so much. So now we have our angle, and it has 3 points. It has a point on each side of the angle, a point on each ray that makes up the sides of the angle, and a point at the vertex, that shared endpoint. In order to name a ray, we have to use the symbol for angle, which is kind of this squished capital L looking thing. And then we choose any 3 points that are on this angle. Two of them need to be on different sides, and one must be the vertex. And the vertex has to be in the middle. And so the name of this angle could be BPK. But like the line segment and the line, order doesn't matter except for that vertex. So another option to name this angle could be angle KPB. So the only thing that stayed the same, the only thing that must stay the same, is the vertex in the middle. Has to be in the middle. If we're only talking about one angle, well, we only have one vertex to worry about. And so we can take one of the easy ways to name the angle and name it by just the vertex. This is angle P because there's only one vertex. There's only one angle at P, so there's no reason to be getting confused. Now, sometimes you'll see multiple angles sticking out of that common endpoint. So I'm going to add another ray, and I'm going to add another point. So now I have this crazy thing. T, P, K, B, lots of points going on. And now if I use just angle P, I would have no way of knowing which angle P I'm talking about. Am I talking about this angle P between the sides that have T and B? Or am I talking about this angle P that has the sides between B and K? Or am I talking about this big angle P between the sides that have T and K? And so when you have this setup, you should use this format right here, the 3-letter format, to name your angle. Or you can number your angles. Now it's clear which angle we're talking about. Angle KPB, this one right in here, can also be called angle 1. This angle here that I added, angle TPB, since it has a number 2, I can name that angle angle 2. So angles usually have 3 to 4 different ways you can name it. Give me a smiley face if you're okay. If you've got any questions or you're confused, type those questions now. Looking at the different chat threads going on. So far, nothing. So I hope everything is okay and that you're understanding how we've named all of these different items so far. So there's my quick review to naming points, lines, planes, line segment, rays, and angles. And so now we're going to get to the weird algebra portion. I said that we were going to use the segment addition postulate and the new one that came out of our flippedmath.com video that y'all have been watching, which is the angle addition postulate. So I'm going to start with the angle segment addition postulate first. So I'm going to need a segment, and I'm going to give this segment 3 points. So I'm going to put one here on the end, and I'm going to give it one here somewhere in the middle. Doesn't have to be right in the middle. It does not matter, just somewhere there in the inside of the segment. And I'm going to give the other endpoint a letter. So here we are with a segment. Now the segment, let me try that again. The segment addition postulate says that if you have a big segment that you can cut into different pieces because there's multiple points scattered here, and this is the smallest case, you can take each individual piece of the line segment and add those lengths together and you'll get the measure of the entire line segment. Pretty straightforward, simple to think about. We're going to write it in symbols. So there's the measure of line segment AB. Notice it looks exactly like the name for a segment, but I left off the segment symbol on top. That means that it's the measure of. So AB plus BC equals AC. And in all cases, we're talking about the measure, the distance between those two endpoints. Excuse me. Now we're going to throw algebra into it. So in order to throw some algebra into it, I need some algebra expressions. So I'm going to say that the distance between point A and point B is 2x plus 6, and the distance between excuse me, points B and C are going to be 4x minus 2. And then I'm going to say that the entire length of segment AC is 20. Oh my goodness. Let's try 28. And the reason for the pauses is I'm making this up for you. I'm trying to kind of guess in my head what numbers I want to use so that I can get whole numbers and not have weird fractions happening to you. So that's why the delay. All right. So now we have our addition, our segment addition postulate that says we can take each piece, add it together to get the whole. And we know now the length of AB. Granted, we don't know the exact number, but we know an expression that could give us the exact number. We know that for both segment AB and segment BC. And we have an exact number for the segment AC. So let's substitute in what we know. We know that the measure of segment AB is 2x plus 6. We know that the measure of segment BC is 4x minus 2. And we know that the length, of segment AC is 28. So now we're going to do our algebra funness to it. I'm going to pull out some more colors here just so that we can keep track of what's going on. Reading my daughter's gel pen stash. Okay, I've got tons of colors going on now. All right, so when we look at this algebra thing, in order to solve algebra equations like this, I'd like to make sure that we line up the equal signs. So every time I write a vertical step, I'm going to make sure that that equal sign stays right there on that vertical line that I sketched with my pencil. That's also kind of acts like a wall, so that way you can think about the left side and the right side. So all of this is the left side, all of this is the right side. Now, this left side looks really complicated. It's big, there's a lot of stuff to it. So before I get to the actual act of solving for x, isolating the variable x, getting it all by itself on one side of the equal sign, I am going to make it simpler. So I'm going to simplify it. And as I'm looking for things to do to simplify it, the first thing that I see and the easiest thing that I see is right here. I see these two numbers that look like regular numbers that I've used since grade school. Very familiar with those two numbers. And so I can think of those, pulling them out and looking at them and going, I have a +6 and a -2. And if I were to add those two together, it'd kind of be the same thing as 6 minus 2. And so I can put those two things together. I'm going to reorder my algebra sentence here, which I'm always allowed to do as long as I keep the signs the same. So there is me reordering it. I'm going to look right here. So if I were to take away everything in front of that, I have this little expression right here that says 6 minus 2. 6 minus 2 is 4. 4 is an easy thing for me to think of, so I'm going to exchange these two numbers right here for a 4. And everything else in my statement, in my algebra equation, is going to remain exactly the same. Give me a smiley face if so far this seems okay. If you've got any questions about why I did something or how I did something, now is the time. Please give me a shout out on the chat thread. Give me a smiley face if everything is okay. And ask your question if you are confused. Give you a couple seconds to make that happen. Don't see any questions coming through right now. So if you've got any questions, again, please speak up. So I'm going to continue on, and I'm looking at this, and I'm looking for other things to simplify. And the next thing that I see to simplify is going to be these two things right here. And the reason I'm looking at these two things right here, wow, this yellow doesn't show up very well. The reason I'm looking at these two things to simplify is because they kind of look the same. They both have a number, and that numbers are from both of them, that number is being multiplied to the same letter, the same variable. In this case, the variable x. So I have 2x's plus 4x's. I can add those together just like I would any other normal number. So I have 2x's right here, and along comes 4 more x's. So altogether, I have 6x's. So 2x plus 4x becomes 6x. And that's the only thing I'm going to change in this algebra statement. Now, if I look at the left-hand side of the equation, I'm going to notice that I can't really do much more to it. I can't add the 6x to the 4 because the 6x has a variable and the 4 is just a number. So I can't simplify it anymore. So now I need to get to the process of solving, of actually isolating the x, getting it all by itself, and that will reveal what value it has to be to make this sentence true. I know some of you have been taught the guess and check method where you just start at the number one and you just start randomly guessing numbers, sometimes in a systematic way in order until you get to 28 equals 28. Not the method we're going to go with here. We're going to very by the rules, kind of like we're opening a present, unwrap the numbers until we get to what the value of x is. Now, as I'm looking at this particular sentence, I'm going to look for things that I want to undo, and I'm going to do that in the realm of, or with the lens of, the order of operations. So I'm going to take a very quick detour, and I'm going to talk about the order of operations. So I'm going to scoot over here. And the order of operations are usually some sort of grouping symbol. So like parentheses, square roots, absolute values, those kinds of things. Followed by exponents. So those are the little numbers like squared things. Followed by multiplication or division. They have the same kind of weight. And then addition, subtraction. Okay, so those are our typical order of operations when we know what the number for x is, and we're going to use that in a sentence like this to figure out what it should equal. But I know what it equals. I'm trying to figure out what this is, so I need to do the order of operations in reverse. I need to go backwards. So as I'm looking at this and I'm trying to wonder, which one should I get rid of first? Go to your order of operations and start at the bottom. I should get rid of addition and subtractions first. This 6x, yes, I agree, being added to the 4, but this 6x isn't one thing, it's actually two. It's a 6, and there's an operation to the x. When you don't see an operator symbol, like addition, subtraction, multiplication, division, it's written like this. When you don't see that, automatically assume it's multiplication. So this 6x represents 6 multiplied to x, 6 times x. And so this 6x thing is going to be sitting on this level right here, the multiplication division level. Since I have this addition by 4, that's sitting right here at the addition subtraction level. So I have to get rid of this piece first. So now I know what I want to get rid of. The question is, well, which operation should I do? Should I do addition or should I do subtraction? This symbol right here tells you this is addition. You undo addition by subtracting. So I'm going to subtract 4. I'm going to subtract. I said by 4. But let's talk about why it's 4. So I'm going to subtract, that gets rid of this addition. Well, how much am I trying to get rid of? I'm trying to get rid of this 4 right here, so that's what I need to subtract by. So I'm going to subtract by 4. This is like a balance beam. So what I do to one side, I have to do to the other. Otherwise, it's not going to be balanced, and the whole thing's going to go blah, and fall and break. So what I do to one side, I have to do to the other. I'm going to put my little bars here to help me keep track of what I'm doing. Plus 4, minus 4, those cancel because 4 minus 4 is 0. It's exactly what we wanted to do. So then I am left with 6x, and I'm going to put that over here. I know it kind of looks like I'm putting it under the 4 minus 4, but that's not really what I'm doing. There's a 0 there, but since I don't need to add by 0, I'm just going to pretend it's not there anymore, and I'm going to shift that 6x over. 28 minus 4 is 24. And so we are left with 6 times x equals 24. So I have gotten rid of all of my addition subtraction things, and the only thing I have left is multiplication and division. Because this is multiplication, 6 times x, in order to undo multiplication, I need to use division. So I'm going to divide. What am I trying to get rid of? I'm trying to get rid of the 6. So I'm going to divide by 6. What I do to one side, I have to do to the other. So over here, I'm also going to divide by 6. I'm pausing to give you just a moment to catch up. All right. Looking here at the left side, I now have 6 divided by 6. Well, 6 divided by 6 is not 0. 6 divided by 6 is actually 1. But 1 times whatever you have here doesn't change that value. So I'm still going to be left with an x. I don't know what the value of x is yet, but I know that 1 times whatever this is going to be isn't going to change it. So I can write just x. If you really want to write the 1 there, you can, but it's not necessary. You don't have to write it. On this side of the equal sign, 24 divided by 6 is 4. So now we've isolated x. It's all by itself on one side of the equal sign because I don't need to write this 1 there. So it's all by itself. And now that it's all by itself, it's isolated, it has been solved for, and its value is 4. And this is how you use algebra in order to help you find the value of things. So that's all well and good, but we still don't know what the length of AB is. What if the question had been, here's your given information, what's the value of AB? Well, we've done all this work, we've uncovered what the value of x is, but I still don't know what the measure of AB is. But I have this algebra expression, 2x plus 6. Whatever the response to that expression, when I plug in what I know for x, that is the distance between A and B. So I'm going to substitute what I know. 2 times, and I'm going to replace the times with a parentheses. So 2 times whatever the value for x is, the value for x was 4. So 2 times 4 plus 6. And now I use my normal order of operations, which is over here in the purple. Grouping symbol, everything inside parentheses are absolute values or square roots. I don't have any. Well, I have parentheses, but 4s, there's nothing I can do. It's just a 4. Exponents, I don't have any exponents, no squares or powers of 3 or anything to deal with. Now I'm in the multiplication division layer. I have a multiplication right here. 2 times 4 is 8. 2 times 4 is 8, and then I'm going to write what's left is plus 6. And now I have just these two numbers. 8 plus 6 is 14. And so the measure of line segment AB is 14. You can use the exact same concept to find the distance between points B and C, the measure of line segment BC. I'm not going to do that with you. The process is exactly the same as here. You're just going to use slightly different numbers. The value of x won't change, however. So I use the value of x here, And I will use the same value of x over here. I'd like to go in and introduce the angle addition postulate. The angle addition postulate, you would have seen it from video 1.3. Trying to use my very best handwriting so it can be picked up by the camera. Postulate. I think I misspelled postulate. No, I guess I spelled it right. Okay. So the angle addition postulate is very similar to the segment addition postulate. That segment addition postulate is what allowed for this example. It allowed us to take a piece of a whole segment, add it to another piece of that same segment to give me the entire segment's length. It's the same concept, but it's using angles. So you're going to need to see a figure that looks a little something like this in order to use the angle addition postulate. Here's one angle. Here's another angle. Notice that all these angles share the same vertex. These are all angles. They share the same vertex. And I've got to name some things. So A, B, C, D. So we've named all of our angles. And the angle addition postulate says that we can do this. It says that the measure of angle ABC, which is this one right here, plus the measure of angle CBD, which is this, equals the measure of angle ABD, which is the measure of this entire angle. So it's exactly the same as that segment addition postulate from over here, but now instead of dealing with the measures of segments, we're dealing with the measure of angles. And the algebra process behind it all doesn't change one bit. Fact, it is so much the same that I can say something like this. The measure of this angle in here is 2x plus 6. And the measure of this angle in here is 4x minus 2. And the measure of the entire angle is 28. So now the information on this problem using the angle addition postulate is exactly the same as the information that was used in this problem using the segment addition postulate. And so the algebra is actually going to be exactly the same. And that's one of the really great things about algebra and about mathematics in general, that once you've decided on rules, especially algebra rules, they're never going to change on you. Take this time right now. We've got 13 minutes left. Give me a smiley face if everything is okay and you've understood everything that we did today and that you're happy at everything that we've accomplished. Please give me that smiley face on the TLK chat screen. That's the one I'm looking at right now. If you have any questions or want me to review anything, please take the time, ask me right now. Right. It doesn't look like I've got any responses from my chat threads, so I'm going to go ahead and close the stream here. It is 10 till 9. I thank you guys so much. Troy gave me a comment. Thank you, Troy, for saying that it was awesome. I'm so glad. I hope this was helpful for you. Please go to the Twitch chat, click on that link if you would please, and um, click on the Google link, the goo.gl, for the survey. If you can't see it on the Twitch channel, you'll see it on my feed. It is right there where the pencil's pointing. Dunk, right there. Take that survey, please, so that I have proof positive that you were here with me. And I hope that this was helpful. The algebra segment made sense. I don't mind doing these algebra portions for you at all. So if you don't have any other questions, Troy, thank you so much for tuning in and keeping me company this evening. I hope that it helped you, and I look forward to seeing you in class tomorrow, and we'll see you on this web stream next week. Thank you again. Sleep, rest well, and have a great night.